In this video, I would like to share some more detail about the Barlow Stem line tracer kit and also code. This code is all written by the robotics people and is very sophisticated. Unfortunately, they didn't have enough room in their own manual to explain the detail. So I hope with this video, I got a chance to share with the details I figured out for you. I think it would be helpful for you to be able to adapt it to your own needs. Let's first run the code. This one is line tracer number 3, the third most advanced user's example. You see there, it will take right turn, it go straight, it will take 90-degree turn, it will follow curve, it will follow diagonals. And we won't have time to go through all the detail, but I want to at least get the basics so that you can kind of figure out the code on your own and build up on it. So let's first see the code. So that first piece of code is you need to go forward, detect the L node, but then go forward, and then it go on. It's gonna detect another left node and take a right turn instead. Take a right turn again. Then go to a curve, go straight, pick up the diagonal, pick up the other diagonal, swing it around. Goes left, swing all around, back, and finish. You can see that it's been running very smoothly. But beneath it, there is lots of detail and code. Let me try to get back here and stop here. Let's see. Okay, let me stop here. I may need that again. So this is the line tracer. The key thing is the infrared sensor right here. So it has 7 NIR sensor. They're all intensity based. This is the bottom view of it. We have the emitter and then the receiver, which is a dark one. So we have, it is looking from the bottom. So from the right to the left, therefore, we go 1, 2, 3, 4, 5, 6, 7 channel. So from the top view, which I'm going to refer to this view for most of the lecture, we have 1 here, 2, 3, 4 right in the middle of the robot center line, and then 5, 6, 7 on the right of it. In the previous video, I already showed people that how to calibrate it. Essentially, the IR file from the manager tool. So when you go to manager tool, each of the IR data will be independent. You can see them. In real time, you're going to get these numbers. And each file data also jive with a threshold. And when that IR reading less than the threshold, for example, like IR file data right now show 113. So right now it's higher than 100, which is the threshold. The bit will be set to 0. Essentially, you see white. When they see some number smaller than 100, that means it has the specific IR sensor number 1 right on is seeing black, essentially. At that time, that specific bit set for sensor 1 will be set to 1. Therefore, you can have a 7-bit called obstacle detected flag from bit 1 to bit 7, and that tells you which sensor see the black. So from there, you can design a very sophisticated maneuver. So in the line tracer 1 route, which is this piece of code is provided for you too, all it does is just go straight and make 90-degree turn. So for the part when it starts to where it detects the first so-called L node here is the job of the function called call L node forward. That means if you go ahead, keep on going forward until you detect an L node, but then go forward. And then the next code or the next function takes over, which is this part here. You keep on going straight until you see another L node, but this time you make a left turn. That's a job for call L node L turn. And then that job is finished, it turn around. The next job, it will be for L node forward because we want to ignore this intersection. So take care of that. The next job, therefore, is detect L node left turn, which is take care of this part. And then, of course, you go forward until you see a T node. At that T node, you make a right turn. And then you see a T node again, you make another right turn. And here you see a T node again, you take a left turn, and so on. Okay, so we'll have the time to get into the detail for the L node forward and L node left turn. And then we'll get some, that's the job of the first video here. Okay, let's see what you mean by L node. An L node means something that go for take a left. It could be that it has a left branch, but it also have a piece of the track that go forward also. So when it does that, with the picture down here, you can see that sensor 1, sensor 2, and sensor 3 all detect the black line. That's a key definition of an L node. When that happens, you have a choice of keep on going forward or you hang on the left. It's possible so you can hang on the right because sometimes maybe they have a goal of going somewhere over here that happen to be lining up with a left curve like this. So it also can be useful. You can think of other ways to use this code. Also, what is an R node then? An R node means that when 5, 6, and 7 detect the black, essentially. And then, of course, you can, at that point, bit 5 and to bit 7 are set to high. Of course, here you can decide to go forward or you can turn right most of the time. But of course, sometimes there's a special case where you need to hang a left, very rarely. T node, like it say, at that time you can see that 1, 2, and 3 see the black, 5, 6, and 7 also see black. So this is a key condition when you define when you find a T node or when the bot detects a T node. So essentially it's a cross. So of course here you can decide I can keep moving forward or I can turn left or turn right, of course. That's the resulting action. So in line tracer, the most very important function called detect black. So this one function here, this function called pull up the IR obstacle detector flag. And what it does have all 7 bits. So these 7 parameter black 1 to black 7 here essentially ended with a specific channel. So that you can basically you split the 7-bit obstacle detected flag into individual bit result, so that you can do specific, very detailed condition like this. Okay. So first function is used a lot called centering, and this is kind of typical how they define function. So they always call detect black. So essentially they get the 7 separate data result bit. So if black 4 is 0, that means that the center line here is not on the black line. So that means what? Either the black line going to be on the left side or on the right side. So within it, they have to dig in some more. So they find if it's either 3, 2 see some black, or 3 see some black, that means S2 or S3 on the black line. That means the black line is somewhere over here. That means the black line is left of S4. That means what? As far as the bot goes, you need to pivot left until S4 see black. That means you're trying to get back so that the black line run along the center line of the robot. And that's what it does. If it detects this, it means the S2, S3 is somewhere seeing the black line, or the black line is left of S4. So you need to pivot left until you see black. To see that's why there's a loop while here, as long as black not 0. That means it see the white piece of paper or the white background here. And then this is just a little piece of code to pivot left at maximum speed. So every time you move a little bit, you detect the black. That means you refresh your data and then you loop again. As long as the black S4 didn't see the black line yet, you keep on pivoting until the little line here starts seeing some piece of black, and then it quit the loop. And then, so when it finishes with if statement, of course, it gets out. But this if statement here is a big structure. It has an else of it, because when S4 doesn't see the black line, this take care of the situation when the black line is left of S4, but they're also possible that the black line on the right of S4, so that take care of the next LF line. The 5 and 6, see the black line? I mean, or another way, the black line on the right of S4 or the black line on the right of the bot. The bot need to pivot right until S4 C black. That's what it does. Here, how important it is. The wheel max speed you normally set at 420, and in the piece of code it's line 10 and 11 here. This is important. It depends on which battery you use, whether you have nickel cadmium, lipo battery. It depends. You may have to adjust these values because they kind of depend on if it's you turn too fast, thing may swing too fast, the timing a bit off, or turning too slow, thing detecting a bit too slow. It all depends. So this part here, you work on your own. You may have to adjust this. Also, as your battery run low, you have other situation also. Next is in the code, you can see that's what it does. Set up the speed. It set up some other initial data. Just no judging time. We get to it. T nudging, no forward time, and then call initialize, where in there essentially it set up different straight speed value and some curve value speed also. Essentially, it could be at 50%, 62%, 68%, or for 100%. And then they use the change speed function to adjust accordingly. Essentially, if the sensor S4 that means center line is seeing the black, it's lined up, the robot is essentially lined up, they will let it go full speed. If anywhere between some sensor 3, sensitive 4, and 5 sensors start reducing down, that means things are offline a little bit, either left to the right of the center line, it start having a little bit less speed. 3 and 5 we are further away from the either left or right side, you're slowing down some more. If you keep on going out of a periphery, you start slowing down more. Essentially, whenever the robot starts seeing black things or don't see anything at all that means it's very far off the line, it's best to slow down because you're already off track. You slow down, you can go speed. So only when you're straight on the line, you can go full speed to gain much time. So that's a setting for initialize. The global time variable for no jigging time is very short. T time is very short. There is a time called node forward time. That means the time for moving forward after detecting any sort of node, so that the two wheels are on the black line again. It's about a quarter of a second for the speed setting that we have here, and of course, assume a certain battery level. And what reason is because the detector, the the array, sensitive array is set up in front of the bot. And when they design their bot, there's a certain distance here that is fixed. And with a certain, like this given speed and given battery level, their estimate was about a quarter of a second for the wheel to go forward enough so it can line up with the black line. The reason why like this is so it's self-localized. If once they take a line or a node, it's going to need to either go forward from there or turn left or turn right. It needs a very precise location, a reliable location, so that it need to know how to perform its move. So that's the quarter speed, quarter second here for this situation. You may have to change that for your specific situation, depending on the battery and then the state of your motor. But that's the idea, because when this thing detects any kind of line and a node, the wheel are still behind the line. So they figured out for their own case that they need about a quarter second for the wheel to go forward so that the wheel will be lined up here. And once you're lined up in situation A here, and then you can easy to maneuver, pivot, that means both wheel turn in the other direction, so you can pivot right on the center, so to swing it around onto either line or curved line. So this is key a very key parameter. You may have to adjust it yourself. Let's look at the detail of two maneuver. They actually, in their code, they have a bunch of maneuver here. And what I suggest is when you see the code, comment it out. And then what I do, I just repeat back only one function and try it one at a time. When this one is done and you figure out how it works, you can put another one in, another one in, another one in. So in the next few slides, I'm going to explain in more detail what actually involved in L node forward. That means go for and basically the bot by default will go forward until you how to detect an L node, but then you go forward from there. So that's take care of this part of the section of the track. And then from then on, basically you keep on going until you find an L node again, which is here, but at that time you turn left node and then you just stop. So that's kind of the example of the line start tracer one start.tsg program, which is included in this book. So what is L node forward do? First, as long as detect no node, which is set to false initialize. So this is essentially the first situation, it didn't detect any node. Therefore, what it does is you need to follow the line and then detect the node. And then it keep on looping like that. Follow the line, trying to detect if there's an L node. Follow the line to see if detect an L node. And what is follow the line? We'll get into it shortly. And then when you detect it, what do you do at that point in time? So once you've done that, because it'll figure out a node, it reset node detect to false again, and then go fast forward for a certain amount of time. So this is the time when it does this, lined up with whatever node it found. So this is the piece of code of it. So let's go into the detail to see what follow the line means. If you go into follow the line, it starts about line 357, and then 659, 660 start here. So what it does call detect black. That means it's going to pick up 7 of those numbers, black 1 to black 7. It is said if black 4 happen to be greater than 0, that means essentially since the number 4 see black line, that means the bot is pretty well lined up, pretty much on the black line. And then it does some final check. You're going to find out to see if either 4 is here and 3 is here. See both black. That means the black line kind of a little bit slightly off the center line only. Slightly off. And then slightly off on the left. That means over here. The black line is slightly off left of the black. And then what? You need to hang a left. Get back online. If that situation not true, and then you check, oh, is it 4 or 5? Which means either black line on the right of the robot, and then obviously you turn right a little bit to get back online again. Else, if none of these things are true, and because you 4 see black, it just right about lined up into it. Because the way the boat is designed is this width here is about the width between a sensor 3 and 5. So if none of these case situation, that means the S4 is right in the middle of the black track. So therefore, go ahead, full speed ahead. You're on the right track. You keep on pulling full blast. So that's the function follow the line. So that means when you do this work, you need to check it. So it's, when it's a short distance here, you can do it. And then also you can start it here and get it offline. You can see that it will, at least you have enough room, so you can see it adjust and get back on the line very well. So that's as part of the exercise if you could do that on your own. So this is a situation when black for S4 see black, the sensor feedback. If this is false, it get into the else if one. That means if black is 0 here. That means S4 doesn't see black. That means we either the black line is really on the left of the bot, if only, and then we don't know. The black line could be on the left or on the right side. So that might is black 3 bigger than 0 or black 5 bigger than 0. And then it goes in and it find the detail. If black 3 bigger than 0, that means this case really happened. And then the black line on the left of the bot, what do? You hang on the left to bring back on the line. If this is false, that means black 5 bigger than 0 is true. So essentially, this is black line right at the bot. Well, you hang it right so that you can get back on the line. Another else if situation could happen is, that means black 4, S4 didn't see black, in black 3, and black 5 didn't see black. That means 3 is here and 5 here. But maybe the black line even up further, that only 2 or 6 sees it. And then, oh boy, you're way off. Well, the black line way off the left of the bot, you turn left more sharply. So you reduce the left speed even more. And then the other way is on the way off the right of the bot, you turn sharply on the right, so you reduce the right speed even more when the left wheel speed is still maximum. So it cranks even tighter right, this is tighter left. And then, of course, the possible situation is somehow the black line is detected way off. So either 1 detected or 7 detected. And that's the next situation is if only 1 or 7 see it and nobody else see it. And then what it does is, like for example, if black 1 see the black, that means the black line is way out here, what you're going to do is you actually lock the left wheel and just crank on the right wheel, trying to bring S4 back in, lock the left. And then the reverse, of course, if 7 only see the black line, and of course, you lock the right wheel, crank on the left wheel maximum to make even a sharper turn to get back onto the black line, to make it S4 sees it. So that's a function of the line. So you can test that by using this section here. You can have way off to the left, way off to the right, and you can see it's going to swing back in. You found out that if you are down here, because the L node is so short, if you're way too much off, it could never recover enough in time. So it will completely miss this node, and then it think this node is objective. And none of the above case. That means the sensor, none of the 7 sensors see any black. That means the black line could be way out here on the right, way out here on the left. Essentially, none of the base happened, and then essentially your robot is lost in space at that time. And what it does, it's going forward at about 6 to 8% maximum speed, and hopefully somehow the IR sensor will see some black line again, and then it keep on doing its job at that time. So far, you know how it keep on following a straight line and adjust so that it stay on the straight line. How can it tell when it detect an L node? Okay, and the code is over here too. So to detect an L node, what it does, of course, it always call detect black, so it get fresh new data, black 1 through black 7, and it found out that 1 see black, 2 see black, and 3 see black. Bingo, you got an L node here, possibly an L node. It may have something over here too, we don't know. So that's why if this condition is true, it goes in and makes sure to verify that either one of the 5, 6, and 7 here, they see that 0. That means they see white piece of paper. If that is true, it can be do. But in this situation here, what it does is only detect the first edge of the black line. So go in here, it turn on the node judging time, and it's called the timer. So it basically just keep on going straight for a very short while, like 0.025 seconds. At that time, it called detect black again, and it invoked the sensor and say, oh, so therefore it get new fresh black 1, black 2, black 3, black 7. And if it does again, it will check that, oh yeah, I see 1, 2, and 3 see black. It goes in and say, oh, at that time, 5, 6, and 7 see white. Hey, I'm for sure now, I am detecting an L node. So that's the job of the L node detect. So now that it detects for sure an L node, what it's going to do? Remember, we have this situation here. we just detect an L node over here. So the wheel are still behind the L node. We need to line up the wheel with the node first. So that's the job of this code. Is as soon as the detect true, it goes out. And after the L node detected, it reset this node. But the wheel are still behind the L node though. So therefore it called fast forward for a little bit, but only for a quarter of a second. So when it does this function, there's this section of code, both wheels are now lined up with the L node. So now we're ready to discuss what happens if you detect an L node. And you detect an L node, what it does is you still going forward to find the node as usual, like the code before. But then once you get there, basically you add a pivot left operation to it. And then same thing, if you find an L node that call L node forward, and then when you found it, you pivot right. If you happen to find an L node and you want to do the right turn, and that's a code for it. And in the pivot, you can see that both will turn one way, the counter one, both of them in a way turn clockwise because they're symmetrical at full speed. And what it does, you can see that if you hang on here, turn the left node, and you can see that key form, there is a loop while black 3 or black 4 or black 5. Because remember first, when it just detects the left node, it line here, and then again it go forward so that the wheel lined up. You need to swing left. And when it swing a left turn, 3 or 4 or 5 here, it could still see black as it turn left. This part here could still see it here. So what it does, as long as you keep on looping it, as long as it sees something black, you want it to turn it. So you really crank a lot to get to make sure that phi is away from any piece of the track that be up in front of it. So once you get that over, which is most like about 45-degree turn all the way, and now then you can concentrate on checking on black 4. So you start turning already here. At that time, as long as black 4 C is 0, that means it's C white. Keep on looping. Okay, until eventually the number 4 starts seeing a little edge of the black line here from its left, I guess. At that time, you stop looping, and then you check the data again. Similarly, they do the same thing for turning right. So they keep on swinging until they see black on the line. Similarly, for what happens if you find an R node and going forward, the same thing. You set it as fall, you keep on following the line, but you call R node detect instead. And it does a similar job as the other one. So you find an R node left turn, similarly at him, or R node up turn. Similarly, they create a function to figure out the T node. When you find a T node, you go forward a little bit. And then, of course, one of the variation is if you find a T node, you're going forward a little bit and then hang on the left. Or T node right turn, that means find a T node, going forward a little bit, hang on the right.